The James Webb Telescope has discovered that the early universe had more than 700 galaxies, a finding not known before. Scientists led an investigation into galaxies that existed only a few million years after the Big Bang. This crucial period of time, according to the standard model of cosmology, is known as the epoch of reionization. During this era, we believe that the universe was filled with a gaseous fog that made it opaque to energetic light. Our models show that only by 1 billion years after the Big Bang did the fog clear and the universe became transparent, a process known as reionization. But boy did Webb prove us wrong. Yes, in a surprising twist, scientists have identified more than 700 candidate galaxies near the edge of the universe. These galaxies have been spotted when the universe was a baby, between 370 million and 650 million years old. The sheer number of these galaxies was far beyond predictions from observations made before Webb's launch. The observatory's exquisite resolution and sensitivity are allowing astronomers to get a better view of these distant galaxies than ever before. Previously, the earliest galaxies we could see just looked like little smudges, and yet those smudges represent millions or even billions of stars at the beginning of the universe, said a NASA scientist. Now we can see that some of them are actually extended objects with visible structures. We can see groupings of stars being born only a few 100 million years after the beginning of time. These new findings shed light on how the first galaxies and stars formed, creating the rich catalog of elements observed in the universe today. But more importantly, this finding also suggests that we may have to go back to the drawing board. And if you think that this is the most impressive feat observed by Webb, wait till you hear this. Astronomers using the James Webb Space Telescope have discovered evidence of complex organic molecules similar to smoke or smog in a distant galaxy. This is the oldest known example of complex organic molecules in the universe found by humans, and it has pushed back the old record for detections like this by about an extra billion years. I don't know about you, but to me it is fascinating and at the same time terrifying that these discoveries at the edge of the universe are changing the foundation of our cosmology. This is a mighty discovery, and here is what it changes. Welcome to space discovery. It's time to explore. Okay, first things first. These chemicals have been detected within an early galaxy that formed when the universe was about 10% of its current age. The carbon-based molecules, technically known as polycyclic aromatic hydrocarbons, are found in oil and coal deposits on Earth as well as in smog. But what is the significance of this finding? Justin Spilker, lead astronomer of the study, makes it very clear that the molecules we found aren't simple things like water or carbon dioxide. We're talking about big floppy molecules with dozens or hundreds of atoms in them. Isn't it remarkable that the universe could make really large and complex molecules very quickly after the Big Bang, when our model suggests that they couldn't have? Given the extreme distance of the galaxy, the light the astronomers detected began its journey less than 1.5 billion years after the Big Bang. The universe is currently about 13.8 billion years old. We are looking at the beginning of the formation of the universe as we see it today. But here's the catch. It is because of Webb that we have been able to detect these complex organic molecules, and it pushes back the old record for detections like this by about an extra billion years. Imagine if we could look farther back in time. Is it possible that we find more of these molecules, and that too extremely close to the Big Bang? Where does that leave our science, our cosmological model? Now here's the thing. Previous efforts to detect complex organic molecules in ancient galaxies could only tell if the chemicals were there or not. With Webb's resolution, we can now see actual details of where within a galaxy the molecules are located. In this early galaxy called SPT 0418-47, the presence of these molecules is not uniform, and the reason for this remains to be explained. Also, this discovery proves that it is possible for galaxies to form in the early universe, where much was thought to be happening. What is fascinating, however, is that the galaxy was already just as massive, and its stars have formed just as much carbon and oxygen as our own Milky Way, even though it's only a tenth the age of our galaxy. It's like a third grader who's already lived an entire career, gone to college, accomplished a career's worth of work, and then retired at age 8. And if that doesn't fascinate you, This finding also proves another theory wrong. Scientists previously thought that these complex organic molecules were linked with star formation. However, the new data revealed this might not always prove true. Spilker and his colleagues found lots of regions with these molecules, but no star formation, and other regions with new stars forming but none of these molecules. The Big Bang took between 500 million to 1 billion years for the first stars to form. That, however, is changing. Well, that's the problem. The James Webb Space Telescope is upsetting the apple cart. All of a sudden, we realize that we may have to rewrite all the textbooks about the beginning of the universe. Telescope into galaxies being born, and oh my gosh, who ordered this? We're finding galaxies in the dark ages. The star clusters in question are called globular clusters, ancient celestial enclaves born approximately 13.4 billion years ago. They are not only the most massive and ancient of star groupings, but they also possess a peculiar characteristic: compositional variation among their stars. Picture this: stars born together side by side, emerging from the same cosmic womb of collapsing gas and dust. Yet despite their shared origins, they exhibit striking differences in the abundance of elements such as oxygen, nitrogen, sodium, and aluminum. This enigma, known as abundance anomalies, has perplexed astronomers for years, challenging their attempts to decipher the cosmic puzzle. Something is wrong. We may have to revise our theory of the creation of the universe. Now, I personally think that the solution to the problem is these are not baby galaxies at all. They're actually monstrous black holes that formed after the instance of creation. That's baffling scientists because they don't fit in the normal sequence of the birth of a galaxy. So I personally think that we're actually looking at monster black holes where perhaps new laws of physics are emerging. And again, if you can figure all this out, there could be a Nobel Prize waiting for you. Undeterred by the challenge, the research team embarks on a quest to uncover the telltale signs of these supermassive stars. They turn to the James Webb Space Telescope's infrared vision, seeking to catch glimpses of globular clusters in their nascent stages. Through the telescope's remarkable capabilities, they peer into the distant reaches of space and fix their gaze upon GN-Z11, one of the most ancient and distant galaxies known to humankind. Situated a staggering 13.3 billion light-years away, JWST captures the galaxy in its infancy, a mere few tens of millions of years old, making it an ideal hunting ground for young globular clusters. It is the distinct nature of light that guides their investigation. Chemical elements possess unique absorption and emission patterns, leaving behind fingerprints that reveal the composition of celestial objects. The astronomers meticulously break down the light emanating from GN-Z11, unearthing two vital pieces of information that propel their quest forward. So we have determined that GN-Z11 contains exceptionally high proportions of nitrogen and an abundance of stars, remarks Daniel Scherer, a distinguished member of the study team and an astronomy professor at the University of Geneva. These findings paint a vivid picture, one that suggests the birth of multiple globular clusters within GN-Z11 and the presence of active supermassive stars within them. With the James Webb Space Telescope as their guide, they will extend their gaze to distant galaxies, exploring more globular clusters and seeking patterns that affirm their theories. As humanity ventures forth into the unknown, armed with knowledge and a thirst for understanding, we are humbled by the magnitude and complexity of the cosmos. And with each breakthrough, we inch closer to deciphering the secrets that lie hidden among the stars. With the way Webb is performing, it is only a matter of time before the universe shines in a new light. What do you guys think? Drop in your comments below, and don't forget to subscribe to Space Discovery, because together we will explore. If you like our videos, please become a member to help us continue to make such content. The universe and everything in it is a mystery that we have only started to explore. With your help, we can bring topics to light that require tons of research and post-production work. Your views matter. Thank you for your time and support. And as always, keep watching Space Discovery, because together we will explore.